This is a Carboline production.
Joining us today on the Red Bucket is Dr. Marcus Foston of Washington University in St. Louis, Missouri. In our discussion with Dr. Foston, we look forward to the future of the coatings industry. We examine the various renewable raw materials that could impact our industry, what they are, why we choose them, and how they are used. All of that and more next on The Red Bucket. Welcome to another edition of the Red Bucket Podcast. Hey, Paul, how's it going, man?
It's going really well, Jack.
We're on the road. This is the first time. We told you guys that this Red Bucket Podcast was going to be different. So we wanted to get out. We wanted to meet people within the industry. So funny story about our next guest. One, he is my neighbor. He's a good friend, Marcus Foston. How's it going, Marcus?
It's going pretty good.
So Marcus is an associate professor of chemical engineering here at Washington University in St. Louis. And I knew that when I met Marcus. We met in the middle of the pandemic, and we became good friends, good buddies on the weekend that do things that dudes do on the weekend and things like that. But
because you could only spend time with your neighbors.
Right. Yeah.
Couldn't go anywhere.
No. But the funniest thing about me and Marcus is probably about a year after I knew him, we finally figured out what he actually does with his chemical engineering at WashU.
He probably talks over your head on most of those topics.
Right.
Huh?
But it was like, wait a minute, you do stuff that's similar to what I do?
Well, actually, no one really knows. Even my mom doesn't know what I do. Really.
Yeah, right.
Yeah, join that club. We have that same conversation at home, too.
So one of the things that Marcus specializes in is some renewable technology within the chemical world, and we're going to get to that. But first, I wanted to give Marcus an opportunity to talk about Washington University and the chemical engineering department here at WashU.
Yeah. So the department is actually called the Energy, Environmental, and Chemical Engineering Department, right? So we study a lot of things that would be traditionally thought of as either environmental engineering or chemical engineering with applications in energy sciences. We have about 22 tenure track faculty. That means they do research, they teach classes, and we study everything from, we have people who do synthetic biology, which is genetic engineering of microbes to make materials and chemicals.
So you're growing humans back there? No, I'm just kidding.
Well, we do.
They grow parts, maybe.
Parts, yeah.
Well, we do try to grow scaffolds, let's say, for how you might, let's say, make the next generation or organ, let's say.
Yeah,
right?
yeah.
Nice. Artificial organ, right? To people who, let's say, think about the atmosphere, right? A lot of pollution is what we'll call aerosol based, which is just a suspension of a solid or a liquid in a gas. And that's what basically pollution is, right? And so we have people who understand the physics of that, they understand the chemistry of that, and then apply that to understanding, let's say, what happens if you have a forest fire. What is the downstream, effects of that?
Yeah, nice.
Absolutely. And it's really interesting. One of the things that we wanted to do with this episode is get into academia and talk to the people who are leading the edge of research and things like that in the area. So one of the things, that I think is interesting is this concept of renewables when it comes to coatings. So, a lot of the times, I think about it, everything that's in a coating, it's hard to say green.
Yeah. Yeah.
I'm just going to be honest here. And a lot of times green coatings come with an asterisk almost like, well, this is more green than that. But the research and what's going on in academia right now is really interesting with what's happening with these raw materials. So let's talk a little bit, Marcus, about being green from a chemistry point of view. People think about recycling, people think about those kind of things that are nature, human nature. But when we talk about being green in a chemical way, or even in a coatings way, what are we talking about?
Yeah, so at least, for me and when we do it in our lab, right, I can maybe start there, is that
right.
we think a little bit about the kind of carbon footprint that a material might have or a chemical that we're producing might have, right? So a lot of people think about going towards green or renewables because fossil fuels are a non-renewable resource, right, that will eventually run out. And even though this is true, the horizon on that is really, really far out, right?
Yeah.
And so we think a lot more about kind of the direct implications of using non-renewable carbon on the Earth's atmosphere, right? So releasing CO2 into the Earth and how that might affect global warming, for instance. We also focus a little bit about, a lot of the materials that we make, in particular plastics that come from petroleum. These are designed to be super stable materials. They're designed to protect things that we wrap it in. But it also means that it won't biodegrade very easily.
Yeah, water bottle will sit on the shelf for a long time.
Correct.
Yeah, they did. I mean, they over-engineered it, kind of,
Yes.
right? Like plastic does what it's supposed to do. It just does it really well for a really long time.
Well, I mean, you could argue that it was engineered to do what it's supposed to do, and it's not necessarily engineered to be a good waste, right?
Right. Because everybody would be pretty upset if all of a sudden the water started leaking on the shelves in the grocery store.
Correct.
Yeah.
Correct. Right. And so we also think a lot about the types of pollution that come from those types of materials. Let's say there's some information that just basically says if we don't do anything about the way we produce plastics and utilize plastics, by the year 2050, there'll be more plastics in the ocean than fish. So,
I mean, I like fish better than I like the plastics.
Yeah,
So,
yeah.
I mean, that is kind of a staggering characteristics because, even as humans, and we don't really need to go far down this road, but it seems like if we use it, it ends up in the ocean.
Yeah.
right. Or there's a lot of evidence now that these plastics, even though they totally degrade, they break down to really, really smaller and smaller particles. Mm-hmm. And it's very likely that most humans now are filled with like what they would basically call nanoplastics, right?
Yeah.
So, yeah.
Yeah, I read one of those articles and immediately regretted that decision. It was one of those things where I was like, oh, neat.
Yeah.
Well, you can definitely bum yourself out, right? But the good news is that a lot of research, particularly in the academic space, is going into how do we think about moving away from these non-renewable resources. And in actuality, we've done a really, really great job with electricity and power, right?
Right.
So, solar, wind, we've made some really, really like big headwinds. Like there are actually industries now that are fairly mature and can exist on their own without a tremendous amount of support from the government, even though I think they do still get a lot of subsidy for that. So.
Yeah, they just, for renewables, did just get a major subsidy. And I think the United States just committed to tripling its number of wind towers by 2030.
Yeah.
So, that's fast. Yeah. That's really fast.
They still need to be made.
Yeah.
I mean, that's 2030 is only 7 years away.
The order is in. That gives us a good starting point for the green conversation because I'm sure, if I was just sitting here listening to this in my car or whatever, I'd be going, but what does this have to do with coatings?
Right.
And so one of the things that we talk about, and we'll kind of talk about this here too, is the traditional way that we have spun how coatings can be green. There's two ways. One is a reduction in VOCs and solvents that are used in the coatings. That is truly getting rid of some of that like fossil fuel type stuff that you talked about, right, Marcus? Just using less of it. That's where we started as an industry.
And it's also very U.S. centric. The rest of the world is not driven by VOCs the way we are here. So it's only part of the problem.
Yeah.
So since this is only part of the answer, we need another approach. We need something else that's going to help bring us full circle into something that's more renewable, more environmentally friendly, more, can we say, just green. And that's where we have to look at what kind of different ingredients, what kind of raw materials, what kind of feedstocks can we use instead of petroleum-based feedstocks. What can we use to help bring us into a more environmentally friendly coating system?
Right. That's exactly what my lab focuses on. So we think a lot about using plant material, essentially biomass, right? And if we think about it, nature's already engineered a plant to suck sunlight in as energy, even though photosynthesis is not super efficient. And then it also can pull in carbon and build itself from the CO2 in the environment. And it happens everywhere. Nature's already really good at it. Billions of tons annually biomass is generated, whether that's for food or for forestry products or just something that's just out there in nature. It's just a lot of it out there. And so as a feedstock, it's available. Right. And so then the challenge is like, how do we then, first understand what those resources are and how we convert them into either products that replace the types of products that we get from petroleum or have even more of a performance advantage, right?
That's right.
Vegetable-based feedstocks aren't necessarily totally foreign to the coatings world. Linseed oil has been used since
generations.
My grandpappy was painting things. So let's talk a little bit about some of the research here and some of the things that are being done. So like I said, linseed oil, but vegetable oils are being looked at very heavily for use in coatings.
Yes. So vegetable oils are essentially triacylglycerides, right? And this is the kind of stuff that, let's say you are taking your vegetable oil and you wanted to make, let's say, biodiesel, right?
Okay.
You'll take that material and you treat it, and that's how you make biodiesel. A byproduct of that would be glycerol, right?
Okay. Yep.
And so these components of the vegetable oil, whether whether the specific structure of it is a triacylglyceride or it's a diglycerol or whatever.
That's 3 or 2.
Right. And they also have mono as well, right?
Singular. Okay.
Right.
Yeah.
So
that's the extent of your Latin. Is that?
That's my chemistry. That's all I got.
Well, that's actually pretty good, right? But despite the specific structure of these, the vegetable oil, you can deconstruct these. You can control the type of chain structures that you, whether they have saturations or unsaturations. If you think about butter, right, like saturated fats versus unsaturated fats. These are all the same chemistries that we're thinking about that go into that we leverage to build handles, to put things on or take things off of these vegetable oils and modify them so that they can be used for coatings, essentially.
That's one of the things that I found really interesting is that it seems like we're figuring out not only renewable stuff, but I think you said something in there about when you turn it into biodiesel, there was a byproduct, and you're looking at that byproduct that probably otherwise would be waste, right?
Right. So, I think the things that we do is we think about renewable feedstocks, and then we also think about waste feedstocks, right? So another potential source would be plastics themselves. So we take a lot of waste plastics, and we also think about breaking those down and then modifying those and turning those in materials. Now, not explicitly into coatings, but a coating is just a polymer. Right?
Yep.
It's just a polymer.
Plastic adjacent.
Right. It's plastic adjacent. My background actually is in polymer chemistry and polymer science. Right. And so a lot of times, a lot of the things that we're thinking about, let's say, to make a material to replace an adhesive or to replace a plastic bag, those can be transported over and applied to coatings as well.
Sure.
I think one of the things that you said, Marcus, that really stuck out was you're looking for handles that you can stick things on.
Right.
And I think that's a great way to look at it is we don't need to actually replace the entire thing. We're looking at parts and how can we make the parts fit together differently. And if you go back to the previous generation of our podcast, we had a lot where we talked about the science and how you have to unwrap the molecules, and we're looking to, when we catalyze it or when we put in the part Bs, and it's literally just letting things go together the way they want to. And by changing some of the parts, we're not really changing much in how the film comes together or how the film can be used. We're changing how do we get to that? How are we carrying it from the liquid state in the bucket to the cured state on the wall or on the tank or whatever it is we're doing? What can we do to make those processes more friendly, more environmentally safe, more renewable?
Right.
And that handle analogy is a really great one. I hadn't heard it put that way before, but that stuck out in my mind.
And the truth is that in the lab that we're working in, there's a lot of really cool things that are going on. You can read a number of scientific reviews that cover.
No, I've tried to. No, you can't.
At least I try to get my students to do this. Right.
Again, here's your Red Bucket Podcast PSA. If you suffer from insomnia, go ahead and Google any kind of science-y journal article. You will not make it through the end. This is my 5-star guarantee. You will fall asleep before you make it to the end of that thing.
And I guess, if you read these journals, there's a lot of really cool research that's been going on. And people, again, are understanding what are the handles that we have in biomass, what are the ways we can convert, let's say, a plant material, whether it's vegetable oil or cellulose or other parts of the plant. How can we convert those into smaller materials, because those are already polymers, how we can convert those into smaller materials that have the right handles, let's say, for something like a coatings. But a lot of that science has actually been explored. But the real question is then how would you do this on a really large scale? And that's the challenge that, my lab tries to think about, right? Like if we could come up with a really interesting way of doing this, let's say, for a gram scale. How do we think about technologies that can be, let's say, something that Carboline is interested in 20 years or 30 years?
Right.
Well, I remember the first time you told me about what you did, and we're kind of leading up to that because you're a specialist in one of these renewables that we haven't even brought up yet. But I remember standing on your back deck and you were telling me about it, and I got real excited. I was like, "Oh yes, let's do this. Let's renewable. I'm in product line manager, marketing brain. I'm like, I can sell this. You can make it. Let's go." And he's like, "Hold on, time out." And then he said the magic words, commercially viable.
Right.
And so that is our challenge, right? As a coatings company, is to figure out how to take the work of experts like Marcus in academia and work with them to figure out how to make these kind of concepts commercially viable. So I think I let the cat out of the bag. Let's talk a little bit about lignin. What is that, Marcus?
All right. So let's think about a tree, for example. When that tree, when we cut down that tree and let's say we're making paper, the paper is cellulose, right?
Okay.
And that's, the same material that we might think of as a cotton, right?
Yeah. Okay.
And when we break down cellulose, we're generating glucose, a part of a sugar that most people use. So we table sugar is sucrose, and part of sucrose is
I store it.
It's glucose, right? So that's the major component of, let's say, wood. But the other component is a lignin, and that's the brownish material that they take out. It has this brownish color that they take out when they're making paper. Right. And I also think of the cellulose actually makes kind of fibers in the wood. Okay. Right. And then the lignin kind of goes around that. It wraps around that. Okay. It kind of is the glue that kind of holds those fibers together. So I always try to make the analogy that cellulose is like the rebar and lignin is like the concrete.
Okay.
That's a great analogy.
And that's something that our
listeners can understand.
Totally understand. Yeah. So what's kind of special about the lignin and where can we use that in coatings? There's been some research and it seems like they've kind of honed in on one area for that.
Well, so the old adage about lignin in the lignin field is that you can make anything from lignin except for money. So,
well, on that note, this has been a great podcast. We'll see you guys later. Join us next week. No, I'm just kidding. Go ahead.
Well, it's actually, wood products. This is something that people have been studying for a very, very long time. And the lignin is also something that people really want to try to figure out how to utilize. Because let's say we're making paper. We know how to make paper. We've been doing it for a very long time. Mm-hmm. And we pull out the lignin. We essentially just burn it on site for process heat, local electrical production.
So it's not totally waste, but it's inefficient fuel for energy.
Well, if we come up with something that we want to do something other than with that lignin than just burn it, it needs to have more value than, say, natural gas, right?
Sure. Yeah.
So it's not that it doesn't have any value, but it's minimized with all the effort that goes into, let's say, growing a plant, grinding it, taking it to somewhere to be processed. We really want to get more value out of that, right? But the problem with the lignin is it was literally designed by nature over millions of years to protect the plant, right? It gives the plant the structural rigidity. It protects the cellulose, which a lot of, like I say, microorganisms.
Okay.
They live off the glucose that comes from the cellulose, right?
Right.
Just the natural carbon cycle relies heavily on cellulose plants falling, and then the cellulose going to the going to the forest floor, and then a number of organisms, using that for a carbon source and energy source, right? So there needed to be something that kept just everything from eating that plant just while it was growing, right? And so it was designed to protect that plant from abiotic stresses like the environment, and then from biotic. And so the design of it is such that there is a lot of potential value in there, but it is very, very difficult for us to extract that value and put it into a specific form or in a consistent form for applications and things like coatings.
But that's a lot of what you do, right? Is try to solve that puzzle.
I work on part of that, right? So, we think a lot about how we understand how the structure of this lignin. So we do a lot of characterization of plant material and the lignin that we extract out as a function of different other processes. So the type of process or pulping process that people use to make paper is going to generate a different type of lignin than, let's say, if I was doing some type of pretreatment for bioethanol production. So I might want to take a woody material, break it down, and then feed the glucose in the cellulose to a microorganism to make ethanol or some type of fermentative product. Well, we're going to do a slightly different type of treatment to the wood, right? And so there's a lot of variation that happens because of nature. And then there's a lot of variation that happens because of the processes that we use to try to extract the lignin. So we try to understand those. And then we try to understand what happens to the lignin as we apply different processes to try to break it down. And then eventually think about what are the best places that we plug that lignin into. And so one of the places that people have really been thinking about is fire retardants.
Right. Yeah, I was reading about this.
Yes. So, and a lot of times in a fire retardant coating, you're just trying to leverage some type of charring capability of the coating itself, right? And
let me just give our quick little dissertation on that. So they use the term into mess, right, when we talk about charring. And we've said it before, if you've listened to a different version of this podcast in the past. Think about the snakes, the little fireworks that you get when you're a kid. You light that little black hockey puck on fire, it grows into a little bitty snake. I always love telling this story because it usually makes the chemist really frustrated because it's an oversimplification of a very difficult process. But that is the same similar thing. When we talk about charring, we're talking about the protection or the growth of the individual product that gives extra protection to the steel. So back to that.
And so biomass, in particular, lignin, has kind of a really specific kind of thermal degradation profile that allows it to be useful as a fire retardant. So it wouldn't be useful purely by itself, but in combination with some other type of matrix, it can become a useful additive just purely by itself. We can do certain things, chemically breaking down the lignin, adding certain types of functionality to the lignin itself to further increase its usefulness in, let's say, a fire retardant.
So is this somewhat related? Like, have you found differences in the types, the sources? We talked a little bit of the different types of biomass and the diversity. Because I know this seems similar. A year or so ago, I was in Northern California. We went through the redwoods and the sequoias, and they were telling us about how the trees protect themselves in these forest fires. Is this some of the same thing? They have a different lignin that's helping to protect them a little bit, possibly, or...
I mean, the overall characteristic that we're leveraging, let's say, in a fire retardant is the same kind of characteristic that you see that essentially trees are deploy, right? Just the presence of the lignin itself can be really useful in protecting some of those outer layers of the wood. So in a growing tree, right? And so this is kind of a similar phenomena, and the question about source is actually a really important one, right? So this is, again, one of the challenges to utilizing biomass in general is that, you can see variations in lignin depending on the species of plant. But let's say we have some genetic clones of each other, two plants, so we can have actually genetic clones. That's actually fairly easy to do.
Yeah, sure.
And you grow them right next to each other. and I extract the lignin, and I will see differences in the lignin. Right. So there's little biochemical control to the polymerization of lignin in the cell wall. It's actually statistically controlled, much like, let's say, a polymer that we might be polymerizing in a reactor, in a plant somewhere. And so there's a lot of variation that just happens from plant to plant. And the question is, how does that affect downstream performance? And in my lab, we may not care about a change of 2% or 3%. Right. But if you're making, a product that you want to sell across the country, and you're making, thousands or hundreds of thousands of tons of this, a 2%, 3% variance just because of source is going to be
be huge.
Yeah. People are willing to pay for green, but they aren't willing to give up performance for green.
Yes.
Right.
That is an interesting factor that you put there, because it's absolutely true.
Yeah. Right. And that totally makes sense. Right. And so like they're only willing to pay so much for it as well. And look, we have to be quite honest that the competing kind of source of many coatings, or even like, let's say, chemicals, this comes from petroleum. And we know how to use petroleum really, really well. Yeah. We know how to produce products cheap. We know how to produce them at scale. Right. And so there's a real challenge to bringing in an immature technology against something as successful and efficient as petroleum.
And mature. Yeah.
And ingrained. Like it is everywhere. Everything that we make almost has some kind of fossil fuel tie.
And it's all regulated. Most of these things are regulated. Yep. They have to go through governmental review, right? And like, so there's a sociology to that as well, right? Which is to say, like, I trust this product. It's been regulated. It's been well tested. And unless you go through the same process, which might take 5 years, I don't want to use this product.
Yeah, I think it's interesting, and I think there's no better example of the performance versus cost is the water bottle itself. Everybody knows that the single-use water bottle is bad for the planet and is going to end up in the ocean, and this is not even really all that debatable. Right. Yet people, like millions and millions and millions, probably billions of water bottles are sold every day in the United States because it's convenient.
And to be honest, you can walk through any amusement park or kids play park or community center, and there is going to be 3 different types of recycling cans next to each other. And inevitably, the trash can is going to end up with plastic bottles or metal cans that could have been recycled that aren't. So the cost barrier is not high. It is sometimes the cost of one extra step.
Right. I can recycle it 10 steps over there, but the trash can's right here. Kind of thing.
It's going in the trash.
So before we completely wrap up, too, you brought up cellulose, and I was in some of the documents you provided to us. I read that they're trying to use that too in coatings is some cellulose as well.
Right. Yeah. So we actually use cellulose in our lab, and we do a lot of different things with how you may blend the cellulose with different materials, and it can modify properties. I mean, we primarily try to use cellulose to modify mechanical properties. So you can kind of etch away at the cellulose until you get like almost single crystals of cellulose. Which means essentially it's essentially a perfect crystal, and it's really strong, but they're really small, right? But we composite these with other materials, and we can manipulate the mechanical properties, but you can also manipulate thermal properties, in particular thermal degradation properties and behavior. And so you can imagine these types of materials being useful in a range of different coatings to manipulate thermal properties, to manipulate mechanical properties of those coatings. And so our lab in particular is really, really excited about this kind of aspect of things. We actually have some projects where we're thinking about how we use cellulose to modify adhesives.
Okay. Yeah. Okay. Yeah, Marcus definitely does a lot of work in adhesives. And I think, one last thing on this topic is, Marcus, a lot of the people who listen to this thing are either engineers that specify coatings, owners that have assets that they have the coating specified for, probably even some coating scientists or researchers listen to this, and obviously constructors and painters. If you had one thing to say to them about the use of renewables and the coatings, what would you say? Yeah,
I mean, I think, the reality is that this is a fairly immature technology, right? But for people on the academic side to really understand the needs of the industry, to be able to start to think about, like, even if it's a 20-year landscape of how we develop things and develop basic science that are going to be really deployable in industry, making that connection with the academic institution, I think that brings value, right? I mean, I understand the landscape of needing to show profit and to be able to be profitable, and not wanting to put a lot of money towards something that is a high risk activity, right? But even if it's just interactions with graduate students, PhD students, even if it's just trying to understand what your in-use needs are, I think these kinds of interactions are super, super valuable. And so I would encourage everybody, that has interest in understanding these types of greener technologies and these greener products, to try to make a connection with academia.
This is really the R portion of R&D. The research.
The research portion, yeah.
Yeah, and it takes time. It doesn't happen immediately, and in most cases, stuff that we work with, people still want to see years of performance testing. Well, you got to start somewhere, and it's going to take years of research to get that product ready to be able to put into something that will then again take years of testing.
Right.
Yeah, so I think that we've covered that pretty well, and we're going to wrap up here with Marcus. We have, as we told you, we want to introduce you to people more than just concepts. So concepts and people. So we have 4 questions that we ask everybody who comes on the show. But the first thing, Marcus, what's a hobby of yours?
Yeah. So, during the pandemic, my wife allowed me to make a nice purchase, which was a Traeger-like smoker, a wood pellet smoker. And so, going out and grilling and smoking has become a little bit of a hobby of mine. I've actually pulled Jack into this, or Jack was already kind of doing it. I see him a couple of yards over, like on his green egg, and so I'm like, hey, neighbor.
Yeah. So if you need a pig roasted, the Marcus and Jack barbecue team is
I've heard
here
about
for
this.
you.
Yeah.
Yeah. So I know all the contenders for this next answer, but I'm interested to see which one's actually going to win out. Do you want to ask this question, Paul?
Are we talking about the sports ball team?
Yeah.
Yeah. So sports fan, I'm assuming you know Jack,
fan,
so
yeah.
you're probably a sports fan too. What's your favorite team, sport?
Well, the favorite sport is football, of course.
Yeah,
right?
I knew that, but I'm not sure which team you're going to pick here. I should know, but
I'm all out for. So I went to Georgia Tech, right? This is the school that I went to. I did undergrad there. I did my PhD there. I worked there for a while, so 14 years there.
Yeah,
I went to every home game from '98 to 2012.
dang,
and went through some good seasons and some bad seasons.
got that triple option going.
Got the triple option going. So that's my team, the Georgia Tech Yellow Jackets. And yeah, hey, I'm a glutton for punishment, but they're going to win a national championship before I kick the bucket. Totally.
Georgia, right? No, I'm just
Well, so this is the thing, so Georgia just won, and I normally was like, I'm not going to say I'm going to root for Georgia. They're in state though, so I'm like, okay, I'm not going to make a big deal about it. But I've always enjoyed the fact that Georgia Tech had won a national championship in '90. And Georgia hadn't won one since the 70s or whatever, right?
Too late.
And so now that's changed, and now I have to actively root against them.
Yeah, so I didn't know if the Falcons were going to squeak in. I was pretty sure it was Georgia Tech, but I didn't know. All right, so in the spirit of some would say baseball, some would say wrestling. What's your walk-up music?
My walk-up music.
Like you're coming into the ring, you're coming up to bat. What music are they playing in the stadium?
Oh, okay. Yeah, that's easy. So I'm from Atlanta, and so I'm a huge Outkast fan.
Okay.
Right? ATLians, if you're familiar with that, right? And so, I personally have tried to now get my 18-month-old to kind of learn a little bit about the music that I like.
There you go.
And the first CD I played her was ATLians.
That's great. And you need to start that soon because I've lost that battle. My wife has turned my 7-year-old into a pop kid.
See, I won that battle because although my son he's 23 now, but he doesn't listen to the same music as me all the time. He came up with Metallica.
And then the last one.
What's your favorite movie? Got a one line, you got a movie line, or a favorite you'll sit down and watch anytime it's playing?
Oh man, so again, I hate that it's all like this, basically the same thing.
That's okay.
Yeah, that's what people want to know.
I'm a huge, like football movie fan.
Oh, you're going there, aren't you?
Well, so we would watch a lot of Rudy.
Okay.
Remember the Titans?
Yeah.
But oh man, it's escaping my head right now. The Program. Yeah.
Oh.
This is one of the reasons that I knew Marcus and I were going to be lifelong friends. We're sitting around a fire and he quotes The Program, which is also one of my favorite movies. That is a little known football movie from the 90s that if you've seen it and you played football, you love it. And he said one of the quotes and I looked at him and was like, you know The Program.
So yeah, the Program is that's just one of the best football movies. We would play it before every game. We play. They had this scene where they were playing Bull in the Ring, which I don't think you can do anymore in football.
No, you can't. You can't. You're not allowed to.
You can't do that.
I don't think you can do that anymore. And it was just you would just get so excited, and you'd be like, okay, I can do that.
Time to go.
Time to go.
So anyway, that's great. Marcus, as always, it's great to talk to you. One of my best friends in life. Thanks for coming on and seeing what I do here for Carboline.
Oh man, this was fun. I really appreciate the invite.
Yeah, it was nice talking with you. Great to get an insight on a different side of the industry and meet somebody new who's doing some real cutting edge stuff and some down and dirty research to help move us forward.
Well, we have a lot of fun doing research, and I hope I didn't completely ruin your podcast. So.
No. Here comes your tech tip for this episode.
You have questions, they have answers. This is Tech Tips.
Hi, this is Chris with Carboline. My tech tip for the day is when specifying fireproofing, make sure that other sections of the spec don't interfere. Sometimes primers might be under a different section, and that can affect how the fireproofing is applied.
As always, thanks for listening. We'll see you the next time on The Red Bucket.